Now, you see, this is a linear combination. See? Let's emphasize this term over here. It's quite used in linear algebra, okay? This is a linear combination between E1 and E2. So I'm expressing E sub theta in terms of a linear combination of E1 and E2. I want to get C and D, okay? The same is analogous what I did for, in this case, okay, A and B, okay? Now, you see, I want C, so I multiply the same, dot E1 is equal C E1 dot E1 plus D E2 dot E1. So, as I did before, this will be 1 and this will be 0, okay? This is 0, this is 1. So, C is equal E sub theta dot U1, which is modulo magnitude of E theta times magnitude of U1 plus cosine. Attention now. What is the angle between E theta and U1? See? This is, attention now, is this angle over here. I will raise here. Okay. I already did before. Okay. Now, I have E sub theta and E1, this angle over here. Okay. This angle is pi over 2 plus the angle here. Okay. That's quite clear. Okay. I'll write here is I'll put that's right, pi over 2, you see, plus theta. Okay. So you can see clearly that the cosine, okay, this is a cosine of an angle, okay, which is in the second quadrant, okay, assuming theta in the first quadrant. So this will be minus sine of theta, okay? So, C is equal minus sine of theta. Now, you see, it's straightforward. How do I get D? I just multiply both sides by E2. So, E theta dot E2, you see, is equal C. I already got C, okay, but I'll put C over here. C E1 dot E2 plus D E2 dot E2. This is 0, this is 1. So D is equal. Now, what is the angle between E sub theta and E2? Just look at here, okay? This is E sub theta and E2. The angle is theta. So D will be, let's put it here. This is cosine of theta. Now, C, you see, I want C. C is equal cosine of theta. So then I can represent, okay, my vector, unit vector in cylindrical coordinates. Look how interesting it is. Then I have, just repeating here, E rho is equal cosine E1 plus sine E2. Now, E theta is equal minus sine E1 plus, sine of theta, okay? Sine of theta. Sine of theta. Cosine of theta. E2. And also I can write EZ is equal, let's put it here, 0 E1 plus 0 E2 plus Z E3. Okay, I'll put it here plus Z. Let's put the, let's put the, let's work on the plane. Okay, this is, I work on the plane. Now look how interesting. I can represent this linear combination using matrix. Okay, this I can write like that. So I have E rho E theta is equal a matrix that multiplies E1 and E2. What is the matrix? You see, cosine of theta, sine of theta, minus sine of theta, and cosine of theta. You see, there's a matrix. Okay? So I can express. Now, it's a good exercise for you, okay, to obtain just the opposite, okay, to obtain xy and x sub 1, x sub 2 in terms of this. That's a homework, okay? My homework, I'll raise here. I put there. The procedure is exactly the same. Exactly the same. See, just to see angles and obtain cosine of angles. That's it. So there's a hint over here. So I'll write E sub 1 is equal, let's call alpha E theta plus beta E rho plus beta E theta. And also E2 is equal alpha beta, let's call eta E rho plus gamma E theta. Now, to get alpha, you multiply the dot product between U1 dot E rho. See? Just multiply this right hand side, alpha E rho plus beta E theta. Okay? Dot E rho. Now, remember now, this is orthonormal. This will be 1, this will be 0. So I get alpha. E1 and E rho is a cosine of this angle. Also the angle between, this will be cosine theta. Okay? You see, the matrix that relates the Cartesian to spherical is just the, in this case, just the inverse of this. Okay? Since they are orthonormal, okay, the inverse is equal to the transpose. So the answer is this. It's easy, okay? No problem. I have U1, 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 E2 is equal A rho A theta. You see? This you see, this is second row. I put the first column right here. And the second row, the second column I put here. Which is interesting. If I substitute A rho and A theta, when I multiply those matrices, you'll be the identity. Okay? That's very interesting. This here is the, if I call, is the inverse. There is a property in linear algebra that when I have systems which are, the bases are orthonormal, the inverse is equal to the transpose.